So this webinar, I will be talking on how you can do performance measurement on Linux using Streamline. So I will give my hardware setup, what you need to get started, and then I will explain a little bit what Streamline is and how you can set it up. And then I will do a live demo, and then there will be a Q&A in the end. So what is Streamline? Well, it's an innovative user interface that brings together system performance metric, you get software tracing, statistical profiling, and if you have an ARM energy probe, you can also get power measurement. So all of these features will be presented to you in the system dashboard. So you can quite quickly identify code hotspots, system bottlenecks, and other unintended effects of your code or at the system architecture level. So my hardware setup for today. So I'm using more or less the same hardware as I did last time. So I have my Z board, which is based on the Sync 7000, which is dual Cortex A9, so it's a SMP system. On top of that, I have my Linux 3.17 running, and I have two connections between target and host. So I have a serial connection, a UART, which will give me a PuTTY, and then also have Ethernet connection, which Streamline will use to pass data to the host. So just to highlight this, there is no debugger connected, so no debugger is needed to do what I'm about to show you. So for this Streamline setup, so Streamline comes with DS5. It works with both Linux and Android, and it has SMP support, so it will be able to tell what kernel did what at what time. So to be able to get this information, we must have something running on target that is passing the data. So there is an agent called Gator, which is running on target. So it can either run in user space or in kernel space. So for the demo today, I will be running in user space. So this comes with DS5, this agent Gator, and it's pre-compiled. So if you have Linux 3.4 or greater, there is no need to rebuild your kernel to be able to benefit these measurements that you can do with Streamline. So before I go into the live demo, for technical questions, please contact me, Björn Skånberg, or if you have any sales questions, please contact one of my coworkers from the respective countries. Okay, so let's go into Streamline. So this is how Streamline looks now. First of all, I need to make sure that I have connection. So I need to make sure that my host is recognizing my target, and it says identify network, and this is good because then I know I have connection. So I have my PuTTY terminal. So I have some applications here. So the one I'm going to show you Streamline on today is the cache test software float point, this one here. But first, let's configure Streamline. So first of all, you need to give the IP of the target. So once this is given, you will click this button, and hopefully it will turn up here. So you see here that I have Gator version 5.23 installed on my microset board, so that's good. Next off, I need to give debug symbols of what I'm about to do measurements on. So I have my VM Linux image, which I'm taking debug symbols from. And since I'm running the application cache test, I will also take debug symbols from this application. So let's go ahead and configure the counters. So this is the counters that I have available. And these are using on-chip resources with the Cortex A cores. So this is available on all Cortex-A cores. So events to collect, I've chosen the default ones, but as you can see, there are quite many different events that are supported. So I click Save. Now we will go ahead and start the recording. So I click Start Capture, give it a name. So you see now Streamline starts to measure. So I will start the application. So you see there will be a jump in CPU activity, and now you see the cache test is finished. So we will stop. Now Streamline needs to process the data collected, so it goes quite quickly. Okay, so this is the results of the measurement of my cache test application that I did. So the top graph is the statistical graph, and the bottom graph gives me what thread or application was responsible for the activity. So as you can see, cache test soft has quite high activity, and it was when the activity get a little jump here, so no surprises. I also get both for core number 0 and core number 1, so we can quite clearly see here that core number 1 is responsible for conducting the cache test application. So if I highlight cache test, everything that's not related to cache test will disappear in the graph, and we will only get performance numbers that relates to this application. If we drill down a little bit, we see that we have some annotations here. So this is the programmer who has been kind enough to give us annotations of what is going on in the code right now. So this is more or less equal to a printf statement. So Streamline will pick this up. All of the annotations will be shown in the log. So I have the array allocation, row major ordering, and then call major ordering. So if I double click on row major ordering, the cross-section marker will span over this area, and we see the performance number for this piece of code. We also, if we have a look at the samples, so we see which functions were responsible for the CPU activity at this point in time. So of course I can decrease and increase this, and I can also drag this across, my timeline to see what functions were executing at that time. So if we go back to core map, we will see that we can give a representation also of what core which core was responsible for what. So for core 0 and core 1, you have the different colors here. So if we have a look in the call paths, we see that we have performance figure for the full test. So from I started the recording and until the end of the recording, I have how much time the CPU spent in idle and how much time the CPU spent in cache test. Also, I have the same type of view for function. However, this is probably not super useful to get all of the numbers from second 0 to second 17. So I will go ahead and adjust these. So the figures I want to show will only be from the start of cache test until the end of cache test. So if I have a look in call path now, you will see that the numbers are a little bit different. So we can drill down in our application and see where we spent most of our time. So same, we can get a function overview of where we spent most of our time. So I also want to mention that these can be exported as reports. So you can export this data and share with your coworkers. Also, it's possible if I double click here, it will take me to that piece of code that is YX loop. So we see here for sum 1D, we see that it was hit 1068 times. And we see that when I click the row, the instruction that correspond to that row will be highlighted. So you see how many times we hit each instruction. So if we go back to our timeline, so if you find also, let's see, we reset the caterpillars. So there's also a possibility to zoom. So you can zoom down to this range. So between 1 millisecond and 1 second. So right now it's at 100 milliseconds. So if you would like to create your custom graph, this is possible. So we go here, new empty chart. So we can call it demo just because it's a demo. So let's say cycles per instruction. Let's say CPI. So if I go ahead and click Control Space, I get all of the counters that have been measured during this run. So I can say clock cycles divided by instructions executed. So in this way we can create our own graph if we need to. And this will of course give the same that you can see both for core number 0 and core number 1. So I think this was it actually. I have said what I wanted to say. So